Hello everyone, I am Archana. Our team name is Syntax Savants, and we, a team of 6 members, are participating in Smart India Hackathon 2023 from Rajalakshmi Institute of Technology. The problem statement that we chose is SIH 1347, a software prescribing Ayurvedic drugs and formulations for a disease based on Ayurvedic repositories. Ayurveda contains a vast library of particular herbs, minerals, and formulations that are specifically designed to meet the needs of each patient, taking into account their age, location, psychosomatic constitution, and clinical state. These facts are dispersed among more than 150 documents among manuscripts written in various scripts and languages. Several classic medical texts are now available in digital form because of advancements in transcription and translational technologies. However, it can quickly become tiresome and unfeasible for an Ayurvedic student or practitioner to shift through this vast body of materials in an attempt to find their drug of choice. Our software application creates an appropriate formulation to treat a constellation of symptoms along with its reference and other needed features. For instance, the writings refer to Punarnavadi Kashaya and Vyagaradi Kashaya in the following ways. These are the two infusions that are recommended for fever and cough. However, Vyagaradi Kashaya would work better than Punarnavadi Kashaya in a patient suffering from upper respiratory tract infections such as common cold. On the other hand, if a disorder is linked to inflammatory changes throughout the body, Punarnavadi Kashaya would be the right answer. Our software application pinpoints the specific medications and dosage forms that are appropriate for a given combination of symptoms.
So the solution goes like this. We are going to create a chatbot. This chatbot accepts input from the user. We will make use of natural language processing to segregate the symptoms. Modules like Spacey will be used for this purpose. Then the symptoms are used in the model to predict the disease. The prescription with dosage is prepared based on the disease, keeping in mind the allergies of every user. The model makes use of three classification algorithms: naive Bayes, random forest, and decision tree. The outcome of the disease is predicted using max voting algorithm from the three algorithms. The user's data should also be stored in the SQL database to track past prescriptions and biodata. Also, if the model gets unambiguous symptoms and is stuck in between two diseases, the model picks the one disease and then asks whether the user suffers from extra symptom, which is not listed in the input. Then after confirming, it makes the decision. For the dataset, we have collaborated with another college. Since Ayurvedic data is hard to get on the internet, we also can get an user biodata from the government website ABHA. We can easily extract the required data. We have also scraped data from reliable websites to further improve the dataset. This is a model for practitioners and students to use, so the accuracy is given more priority. We can also further increase the reliability by adding more classification models to predict the disease.
Here are the use cases. Our software finds usefulness in various fields. It enables researchers to analyze the relationship between Ayurvedic formulation, disease, and pharmacological properties, potentially leading to the development of evidence-based Ayurvedic treatment. Our software makes Ayurvedic knowledge more accessible to the practitioners worldwide. Ayurvedic colleges and institutions can incorporate their software into their curricula to provide students with practical tools and reference for the studies. We are going to implement some of the unique features in our software application. Since India is a very diverse nation and has a lot of language spoken, we have taken that into account and plan to on using the Google Translate API to translate all the popular Indian language used. We also taken into account the possibility of a patient having allergies. We will save all the allergies in their respective records. This will be helpful in giving better prescriptions. Some diseases may have multiple names. We have used a reliable dataset to figure out all the disease name and provide the user with more information.
Next, I will show the app design we have created using Figma. We have created a simple yet functional user interface. We created a login page on which user can register or login. If the user is new, then we will also request the user's biodata to be saved into SQL securely. If the user wants, they can also specify the ABHA number. After registering, the user is redirected to the chatbot interface. Here, the user can type out his or her query. This query is sent into the NPL model and the model predicts the disease. The disease and prescriptions are printed out below the query if the chatbot needs it. It can also cross-question for more data on the symptoms to generate a more accurate diagnosis.
In conclusion, we are happy and proud to be a part of Smart India Hackathon 2023, and we want to thank the Government of India for this opportunity. Our chatbot will greatly benefit Ayurvedic medical students and practitioners. We request the organizers kindly consider our proposal during shortlisting. Thank you once again for this opportunity to make a positive difference in the field of Ayurvedic healthcare.